Yes, Bhaiya.
Okay. So you are able to
I didn't understand. Sorry.
you were able to follow those.
Uh, I won't say I followed everything. I'm having a little problem understanding the whole thing.
Okay.
I hope I'll get over it in 16th week.
Okay. Yeah, that will be okay. So the next exam is on 16th week.
Yes.
So make sure that you do everything by then. That will be fine.
Yeah.
So okay, during last class we completed our journey of exterior algebra. Now we can actually jump into the new section, that is exterior calculus, which will definitely use exterior algebra a lot, but calculus is much more fun than algebra. So if you guys have any question regarding any of the classes we had so far, you can ask now. Within 2 more minutes I'll start, and also try to be on time, do not be late. Do you have any questions so far, particularly regarding the previous lecture or any lecture we had so far? Question?
Bhaiya, can you hear me?
Yes, I can hear you now.
Okay, actually, I'm a bit of sick, so it's tough to do today's class. Can I record the class?
Okay, you did that in the last class as well, as I remember, right? Like you were not after the half time, I believe.
Yeah.
Okay, yeah, you can record, but it's better to be present in the class.
Yes, but I have some symptoms of COVID-19, so actually it's tough to stay. So,
Okay.
so it's 4 hours long. So I think it would be better for me if I record the class. And I will be here as much as as I can actually.
Okay. Aren't you vaccinated yet? Take the vaccine. Like you have already COVID-19 symptoms, so you cannot do anything about it. But for the others, you have to take the vaccine. Okay, I think we can start. So far, we have learned a lot about algebra of the system. Here, a system means like uh, how to deal with this coordinate invariant formulation of calculus, right? Our so far we have been dealing with tensors that are completely antisymmetric. Either those are p forms or p vectors, right? And many of the things that we encounter here can be done without any notion of metric tensor, but some of those will require you the metric tensor, like host dual. You cannot proceed without metric tensor. So now um, we are ready to learn the calculus portion. We'll start with the derivative. we'll start with the derivative. The derivative here is called the exterior derivative. The exterior derivative, and it's denoted as d. In the book you'll see it's a bold-faced d. It's not a d like this. It's a sans serif d. It's not a serif d. It's a sans serif d, and with a bold-faced notation. And here I am going to use a lower bar instead of bold-face. So this d and like this d and this d are two different d we are encountering here. So we already know how to use this partially because we have introduced how to use this thing on a scalar field. But if something is a form like one form alpha, we do not know how to apply this thing on that. So let's begin by like having some like we already have some idea how to take derivative of a vector object. So let's like extend that idea into this. So if one form alpha is written as like alpha mu dx mu, then our question is, what should be the correct formulation for d alpha? So how should we define this? That's the question. So one guess could be like this. As we have like the components and these are the bases, so probably we want just derivative of the component, and as d is a we'll introduce another one form basis, we'll just direct product with this thing with that basis. So probably, we are not sure though, it might be useful to introduce this derivative like delta alpha mu over delta x nu. Then dx mu we already had that, then times dx nu, like that. So question is that a good formalism or not? So let's see, like this part is the tensorial part. So the overall, definitely it's a tensor. It's not a problem. It's a tensor already. But what happens when we change the coordinate into a new one? So say we could write our alpha in a new coordinate system like this. The same alpha we could write like alpha mu prime dx mu prime, like that, in a new coordinate system, right? So in that new coordinate system, d alpha, presumably it should be like this: delta alpha mu prime by delta x nu prime dx mu prime times dx nu prime, like that. So if we change the coordinate from here, because we want this thing and that thing to be tensors. Why? Because tensors are the two geometric quantities that do not change over the when we change the coordinate. We change the coordinate. So that's why we want our d alpha to be like the derivative of alpha to be a tensor, because that will become a coordinate invariant quantity. So okay. So let's check if we define this way. Question is, when we change the coordinate, will this thing becomes this? That's the goal, right? That's the basic goal. So how do we proceed to see that? So change the coordinate individually, then take the derivative. That's we have done here. Also, we had a relation between the coordinates, right? We had a relation between here, like alpha mu prime, not coordinates, like the components of one form. Alpha mu prime was related to alpha mu. How is that? What should be the factor? Hello.
I guess del x mu by del x mu prime.
Del
I
x mu
think
divided by delta x mu prime.
mu prime.
Yes, yes, that's what we expect, right?
Yeah.
So now, if these two things, like these two things are d alpha, right? So, and these are the bases, these are the bases. So our components should transform like, if it is a tensor, then uh, we expect that the coordinate varies like this. Not the coordinates, the components varies like this when we change the coordinates. Times, what's the factor? We're just changing the coordinates, so that's your assumption, like we should get this. So what should be the factor usually if this thing is a will be a tensor?
Is it? I think it's mixed tensor, isn't it? One is upper, one is lower.
No, both are lower.
X mu, isn't it upper? X upper mu.
No, you have that on the downstairs.
So
X mu is on the downstairs, so overall x mu is the downstairs, so that's not a like mixed tensor, like 1-1 tensor. It's a 0-2 tensor, if it is a tensor at all, like it's a component of a tensor at all.
then I expect delta x mu by delta x mu prime.
Delta x mu by delta x mu prime.
Mu prime.
And
delta x mu by delta x mu prime.
Delta x mu prime. Yes. If these things are the component of tensors, then it should vary like that.
Yeah.
Now let's see what happens when we change the coordinate on this object using the coordinate transformation rule of alpha, because we know this relation is for sure, right? This thing is correct. We are not sure about this relation. We are trying to check if this thing holds or not when we change the coordinate. So use this thing, and we already know how how you take the chain rule of a partial derivative. So let's start with that.
I have a question. Yeah, I did not understand the red box one. Why it is so? Could you just repeat?
So if this thing is correct, with the definition, it's a coordinate independent definition. Like when you go to a new coordinate system, you get this, like you had in old coordinate system, you had delta alpha mu over delta x mu. When you go to a new coordinate system, you get delta alpha mu prime over delta x mu prime, right?
Yeah, got it.
So now, as we are demanding that this thing is a component of the same tensor, d alpha, just written in different coordinate, they should be related by the coordinate transformation. The way that the inverse way that this basis system changes. You can just expand this thing.
Okay. Okay.
And that will be this. But there is another way to find the transformation relation between delta x alpha mu by delta x mu with delta x alpha mu prime with delta x mu prime. That is, use the transformation rule for alpha, component of alpha, and use the chain rule for partial derivative. Let's see what happens. If the results matches with B, then we are fine. But if it doesn't, then we are in trouble because we cannot then define this way.
Mm-hmm. Okay, got it.
Okay, so now according to chain rule, we can expand our partial derivative like this. We want to take derivative with respect to x mu, x nu, delta delta x nu, then delta x nu by delta x nu prime. So we have already found that factor, right? This part. This is over there, and then we have alpha mu prime. Just expanding the chain rule. The trouble actually begins when we expand the other one. So it's delta x nu by delta x nu prime. That's fine. Then delta delta x nu of this whole thing, that is, substitute the transformation rule for alpha mu over there. So that will give you alpha mu delta x mu by delta x mu prime, right?
Yeah.
We just use the transformation rule for the component of alpha itself. So now take that derivative considering the product rule. So if you consider the product rule, the first term, like you have to use like UV, right? UV method. So then you get delta alpha mu by delta x nu times delta x mu by delta x mu prime times delta x nu by delta x nu prime. That's one term. But then you have an additive term, that is, because of the product rule you get this alpha mu times delta delta x nu of delta x mu by delta x mu prime. Then you have that product term, that is this. So is that what we expected? Do they match?
No. No.
No. No, they do not match. So that means the way we try to define our derivative, the usual way, like just take the derivative of the components. So that's not a good way to do that.
Yeah.
Okay, so let's try a new definition. Let's try a completely antisymmetric definition. By completely antisymmetric, I mean when you take the derivative of one form, you get a two form, not instead of like getting a just any arbitrary 0 to tensor, you get a specific two form. So they did not have any symmetry property between like these two indices, but now we demand a symmetry property that is completely antisymmetric. So if we can define that way, that might solve this problem, because then you will see that this term actually cancel for the antisymmetry. So okay, let's try a new definition. So our alpha is already alpha mu x mu prime, sorry, dx mu prime, or alpha mu dx mu, and we demand our d alpha is defined as delta alpha mu by delta x nu, then dx nu with dx mu. I think that's the definition I want. So let me check, like if I want that one or the switched one. Okay, it's So yes, the derivative one gives the first one. Okay, yes, that's the correct one. Yes. Okay, so if I define that way, then what happens? Then what happens? So when you go to a new coordinate system, some primed coordinate system, so then your same d alpha, due to the coordinate transformation of this basis to form, you'll have like delta alpha mu prime by delta x nu prime, then dx nu prime with dx nu prime, right? Where this thing and that thing, we want those to be related by, like we assume those to be related by delta alpha mu prime by delta x nu prime. Tell me how we want it to be related, because it's a component of tensors. So how do you want it to be related?
Delta alpha delta nu by delta x delta nu, and we'll get
Okay, delta alpha
delta
mu
nu
delta x nu
and
times delta x
mu by delta x nu prime.
by delta x nu prime, and delta x nu prime by sorry, delta
Delta
x
x nu by
by delta x nu prime. Yeah, this is what we want actually. So that's, now check with this new definition, does this thing hold or not? It's a complete antisymmetric definition. So here we need to remember one thing, one property of this, like consider, like let's rename it. So let's call it say beta nu mu. I think that would be helpful, right? Let's call beta nu mu equals to like delta alpha mu by delta x mu. Let's call it this way. I think that will be helpful. So we know one symmetry property, that is due to this part, this completely antisymmetric part, this beta mu nu mu should satisfy this thing as well, right? Because of antisymmetry, complete antisymmetry.
Yeah, it should.
Or actually, if you are confused about like direct derivation this way, I think I can give you a better way to understand this thing. Okay, let's not do this
Is it
way.
the antisymmetric property? I think it's symmetric property. There shouldn't there be a minus?
Minus sign. Yes. Sorry. So I think I can give you a better derivation for that, because it might not be that much visible the way I'm doing, because then you have to use this thing explicitly. But instead of doing using this thing explicitly, let's expand those things. That will be helpful, I think. Expand those things. So if you expand this d alpha, and like instead of writing in wedge product, we want this to be written in direct product. What happens then? So delta alpha mu by delta x nu, that's okay. Then we have dx nu times dx mu minus dx mu times dx nu, right? Like that.
Yeah.
Okay. How do you proceed further? Okay, yes, let's do this way. Okay, we are almost there. So separate those two terms, delta alpha mu by delta x nu, dx nu times dx mu We can do that. Then minus delta alpha mu by delta x mu, that's fine, dx mu times dx mu. So for this, the second part, we can actually switch the indices, means we can rename the indices, right? We call the mu index by nu and call the new indices by mu. We could do that, right? Those are dummy indices.
Yeah. Yeah.
So let's call these indices to be new. Like this dummy index, we can change this. We can rename this. So and also we can rename that thing as well. Okay. So now you can actually collect those things in a single term, that is delta alpha mu by delta x mu minus delta alpha nu minus delta x mu. So then you have dx nu times dx mu. Now let's call our d alpha to be beta. Beta equals, like it's a name we are assigning. So then the component of beta, so beta nu mu would be like this: delta alpha mu by delta x nu minus delta alpha nu by delta x mu, right? That would be the component for beta. Is that clear?
Yeah.
So now the like symmetry property is kind of apparent, because that's basically if you switch the indices, like let's switch the indices. So what would be your beta mu nu? Beta mu nu would be like delta alpha nu by delta x mu, right? Minus delta alpha mu by delta x mu, which is basically negative of the upper one, which is beta nu mu, right? So that if you define this way, first thing is that the components are basically completely antisymmetric. Like when you switch the two indices, it gives you minus sign, right? Is it clear to everyone?
Yeah.
Okay. Okay. Now let's see that if from here actually, remember that our beta nu mu is defined as this. So let's write the same thing, beta equals to d alpha, in a new coordinate system, and that's gonna be like delta alpha mu prime by delta x nu prime, right, minus delta alpha nu prime by delta x mu prime, then dx nu prime times dx nu prime mu prime. That's it. And we are going to call this part to be the component for beta, which are beta nu prime mu prime. So from the way we have written, it's apparent that beta nu prime mu prime is related to beta nu mu by the relation delta x nu by delta x nu prime, delta x mu by delta x mu prime. That's kind of apparent, because how you prove that? You just expand this part and collect everything, and you'll see that you can match with the upper one, right? That will give you this relation. Okay, now if we use the definition of alpha explicitly, like the transformation rule for alpha explicitly, can we see this relation again? So if we can, then this definition of derivative is correct. It's coordinate. If we cannot, then we have to think about new definition. Okay, so let's start with this part. So beta mu prime equals to, in terms of alpha, what are those? Just I have written over there. So that is delta alpha mu prime by delta x nu prime minus delta alpha nu prime by delta x mu prime. So use the transformation rule for alpha explicitly. Also use the chain rule for derivatives. So if we use the derivative first, then you'll get delta x nu by delta x nu prime. Then you'll have like delta x nu on alpha mu prime, and the same thing is again on the other side, delta x mu by delta x mu prime, then delta x mu on alpha nu prime, right? Hello?
Yeah.
Is the calculus like the chain rule application, and are these things are clear? Like, are these things clear enough to you?
Yeah. It's clear to me.
Okay. Then now we substitute alpha mu, the transformation property of alpha mu prime as well, right? So we have like delta x nu by delta x nu prime, then delta x nu of alpha. I want to substitute alpha mu prime, so that would be alpha mu delta x mu by delta x mu prime, right?
Yeah.
And then you'll have on the other side, you'll have like delta x mu by delta x mu prime, delta x mu of alpha nu prime. What's that? How do I substitute that?
Alpha nu
Then
delta x
delta
nu by delta x nu prime.
nu prime, right? So now use the product rule again, the same way we did previously. So if you use the product rule, then the first term here, first term in the product rule from here will give you delta alpha mu by delta x nu. Then you'll have delta x mu by delta x mu prime. Then the other part like delta x nu by delta x nu prime, right? Then you'll have an additive term from the product rule. What's that? Alpha mu delta x nu of delta x mu by delta x mu prime, right?
Yeah.
And then delta x nu by delta x nu prime, right? Okay, and then expand the other part. So minus from here, so you have like delta alpha nu by delta x mu, then delta x nu by delta x nu prime, then delta x mu by delta x mu prime, right? And then you'll have minus alpha nu, then
delta x mu by delta x mu prime,
of delta x
mu by delta x mu prime.
mu by delta x mu prime. Then
And then the first one, delta x mu by delta x mu prime.
delta x mu by delta x mu prime. Okay, now can you see that these two terms are same? I believe you cannot. So we actually need to rename the indices such that they matches. Like just remember not to switch to prime to unprime. That will be fine. So if you remove like mu prime, you have to substitute something like lambda prime or mu prime. So we are actually switching between mu and mu. That's all. So this one, instead of writing mu, I'm going to write it as mu. so as this, and this one, instead of writing mu, I'm going to write nu. Hmm?
Yeah, that's correct.
Okay. Now, now it's almost there. Instead, oh, I have another property that is switching two indices, like switching the indices of beta, nothing changes, right? Like, yeah, nothing, it's not correct, like changes by a minus sign, right?
Yeah, a minus sign.
A minus sign, okay. Surely the derivative 0 should be seen from here as well. Okay. I think fair enough. Let's proceed. Let's proceed. We're almost there actually. So I have to substitute the basis as well. Okay. So okay. I have this 4 term, and this is basically beta. What did we expand? Beta mu prime, right? Mu prime. Hmm?
Yeah,
Beta mu prime. Okay. So now let's construct the full beta. Full beta would be like beta mu prime times dx mu prime times dx, or it's the opposite actually. Right. Oh, here I believe I made a mistake in the index, right? It should be mu prime, right? Just look into here, because when you have delta alpha mu by delta x nu, that was your new mu, not new mu. So nu was the first one. Nu was the first index and mu was the second index. So that's how we need to write as well. So here I made a mistake actually. So that's how we defined our, yeah, this is the correct thing. Okay, so yes, so we had our beta mu prime times dx nu dx nu prime times dx mu prime. Now substitute everything. But it should be apparent from here as well. See that. Everything matches with the upper one. Okay. The way we change the indices, the dummy indices. Okay. Okay, I think I cannot see it from here, so I have to eventually I have to substitute everything. Otherwise, I cannot see it from here. Okay, yeah, it's the harder way to see it, but it should be apparent from here as well. That's what I want. Okay, let's write this term and that term first, because that's not our concern right now. So I can write delta alpha mu by delta x nu, delta x mu by delta x mu prime, delta x nu by delta x, it should be prime, right? Yeah, it was
Yeah.
prime.
Right.
Nu prime minus delta alpha nu by delta x mu, delta x nu by delta x nu prime, delta x mu by delta x mu prime, times we have like dx nu times dx nu prime times dx mu prime. And let's not worry about this first part. We have to worry about the second one. So that is plus the other part. So that is alpha mu delta delta x nu delta x mu by delta x mu prime, delta x nu by delta x nu prime minus alpha mu delta delta x nu of delta x mu by delta x nu prime then delta x nu by delta x mu prime. Then we have the last part, that is dx nu prime times dx mu prime. Okay. Okay. It shouldn't be this hard. Like, I'm getting into more algebra that I need not to. It should be apparent from this step already. I have a definition for beta mu prime nu prime mu prime mu prime. If I switch the indices, okay, pardon me, actually I need not to do this part, as I can see it. So basically switching these two indices actually resolves the issue. Like that we can already, I can already see that. I need to show you too as well, because all I have to do, if I do this way, I have to do like, then at some step I have to switch the indices again and use the property eventually, and then I have to cancel these two terms. So instead of doing that, as I can see it from here, like if I switch the indices, this term becomes that and that becomes that. So the rest are like these are that, these are the equal and opposite of each other. So I can show it from like the definition of b mu prime as well. So just give me a moment. Sorry, I'm really sorry that I actually should not do this way. Okay, so the thing we got beta mu prime, which is this whole part, So let's write the opposite one. So which is beta. Oops, this is mu prime. So let's write beta mu prime out of that. Beta mu prime out of that using using the same thing. So what do we get? So it becomes the first term becomes like delta alpha nu by delta x mu times delta all the nu become mu, so delta x what it should be nu, yes. So the mu prime, then delta x mu by delta x mu prime. Okay, then this part you'll have like delta alpha mu by delta x mu, delta x mu by delta x mu prime, delta x crap, I should switch mu not primes. Sorry. Just today. I'm switching the primed ones. So this. Let's do it in a little bit slow manner. I think then I can do it without any trouble. Okay. Minus, then you have delta alpha mu by delta x mu, delta alpha nu by delta x mu, delta x nu by delta x mu prime times delta x mu by delta x mu prime. Okay. So now the other part, we have like plus alpha nu delta x mu. Oops, I'm doing the same crap again. Oh, no, I don't want that. I want this. Delta x mu by delta x mu prime, delta x mu by delta x mu prime. Yeah. Minus alpha mu delta x mu of delta x mu by delta x. I'm now switching the indices, so it will be like mu prime delta x mu by delta x mu prime. Did I copy it correctly? I have to copy everything except for when I have mu prime, I have to write mu prime. When I have mu prime, I have to write mu prime. Is that thing correct? Because I was not able to focus that much. So you guys please check it a little bit. I think then it will be fine. If you can check and confirm that these are correct, then
I think it's correct.
okay. So now the relation between beta mu prime is this: beta mu prime plus beta mu prime mu prime is 0, right? Due to the antisymmetry property. So we are supposed to add all those terms. We are supposed to add all those terms and set it to be 0, right? Because beta is already antisymmetric. By the definition, beta is antisymmetric, right?
Yeah.
So add all those terms and set this part to be 0. Okay. So when we are adding, like we have to add 8 terms. So this side, this term adds with this term, and this term adds with this term. So it's not much helpful because they are on the same sign, so we cannot see that they cancel or not. So we have to change, like we have to switch the indices, like the dummy indices we are going to switch. So here, instead of writing this here in this sum, instead of writing mu, I'm going to write nu, and instead of writing nu, I'm going to write mu. So if I do that, then this thing becomes new, this things becomes new, right? And this thing becomes mu, this thing also becomes mu. I just change the dummy indices, that I can do, like the summing index.
Yes.
Okay. Now here, if we do the same thing, mu becomes mu, nu becomes mu, and mu becomes nu, right? So now we can see that these terms actually cancel, because here I have like delta alpha nu by delta x mu times delta x nu by delta x nu prime times delta x mu by delta x nu prime. So that term and that term, when you add, they cancel out. Also, delta alpha mu by delta x nu, this term cancel out this term. Can you see that?
Yes.
This 4 term cancels. Then we are left with the rest one, that is this part. That will actually tell us the relation between that two derivative that we have been struggling with. Okay. So can we simplify this calculation a little bit?
I think it's also 0. Also cancels each other.
Can you see that?
Yeah, they match and they have opposite signs.
Which thing match?
First and fourth, second and third.
Okay, yes. If you can see that, then that will be helpful. So first and fourth, they match, right?
Yeah.
And this one
Second
and
and third.
that one match. Let me check. Okay. So yes, so it means that only these terms, like these 2 terms, are actually completely antisymmetric, right? So yes, so basically we got, if you factor out alpha mu, and then you have the rest of the other term, that is delta x nu, or delta x mu by delta x mu prime. And actually, as you can see, I need not to write it, right? As you can see, I need not to write it. Like I'll just write it because yes, I can see it as well. So this term and this term, they cancel out, and this term and that term, they cancel out, right? So if we give this thing a name, if we give this thing a name like first term becomes third term actually, and that cancel with the fourth one, which is I want a relation between these two actually, this one and that one. That's why actually I'm bothering just writing 0 equals to 0. I want a relation between those two that I can show that actually they cancel.
Can we get such relations from 0 to equal to 0 situations? I mean, they just cancels out.
No, there is a symmetry property. That's why like they cancel out. So I want to use that directly. That's what I'm saying. Okay, let's match when like actually the basic thing I need like I need to match this term with that term. So I'll write the in such a way. When I switch this two term, then crap, I'm already losing a lot of time here. It's a simple thing. It's taking so much time. So what it means like this part is already completely antisymmetric, right? On regardless of the other part, this part is already completely antisymmetric because that's why you are getting 0. So when you switch those two things, you get a minus sign. Oh, okay. So I have a minus sign already there. just let me check. I think I made a mistake somewhere. Otherwise, it will be like apparent from here already. Just let me check, please. Delta alpha mu prime by delta x nu prime. Delta x. Okay. Alpha mu prime.